Welcome to EDU World Space.
Let's talk about this question. We are given that a charge of 4.15 microcoulomb is placed at each corner of a square zero point 0.1 meter on a side. All right, let's just draw a rough figure. It will help us to understand how they are positioned and how to move further. So this is a square, and we have at each corner we have a charge. So there's one, there's two, there is three, and there is four, and it has a magnitude of 4.15 microcoulomb. Let's represent it by Q at the moment. The length of each side is also given. That's zero point 0.1 meters. And this is also zero point 0.1 meters as that's a square. So we have to determine the magnitude and the direction of the force on each charge. All right. So the direction will definitely change, but the magnitude is going to remain the same because the figure is symmetrical. So let's say we find out the force on this particular charge. So that force is going to be due to three charges. One is because of this charge q. So since the charges are all equal, the force is going to be repulsive in nature. So let's say because of let's mark these for a better clarity. We have this position at A, we have this one at B, we have this one at C, we have this one at D. So the force on A due to the one which is placed at D, that's going to be if that's F, then the is going to look like this. And likewise, if the force on A due to B, that also has to be F because the distance between these two charges, these two set of charges are equal. So that's also going to be F. The only difference is the direction will be over here. And what is the force between C and A? That's going to be something different. That's going to be something different. So force on A due to C, that's going to be, let's say, F2. So F2 is going to look something like this. It will point diagonally, and we know that the diagonal of a square is at 45 degrees. So this angle is also at 45 degrees. All right. Now we have to find the resultant of F, and F2. Let's first calculate the values of what the F and F2 is. So the force is going to be K, Q1, Q2 is going to be Q square over R square. So R square is going to be zero point 0.1 square. So that's how it looks like. 1 over zero point 0.1 square, and 1 divided by it is going to be 100. So this is 100 kq square. This is the value of F. And likewise, what is the value of F1? What is the value of F2? So F2 is going to be again KQ1 Q2, which is Q square, or R square, where R is the length of the diagonal. So if this is zero point 0.1, this is zero point 0.1, then the diagonal is zero point 0.1 root 2. This is as per the Pythagoras theorem. So if this is zero point 0.1 root 2, then we have to place zero point 0.1 root 2 over here. So that's going to be zero point 0.1 root 2 whole square. So if you simplify this, that's going to come out as 50 kq squared. This is the value of F2. Now we have to do the resultant of these three forces. So for F and F, these are at 90 degrees with equal magnitude. So their resultant has got to be. Let's draw the figure over here to have a better clarity. So if F is over here and F is over here, then the resultant will be at 45-degree angle because their magnitude are equal, and the magnitude is going to be F root 2. This is as per the Pythagoras theorem. So this angle is also going to be 45 degree, and we already have an F2 in the same direction with the magnitude of let's write the magnitude later. So this is how the resultant force looks like, and we can now definitely place the values of F and F2 to get the resultant force. So F net is going to be F root 2. F is K 100 kq square, plus F2 is going to be 50, and there is a root 2 as well, and this is 50 kq square. So kq square is taken, in fact 50 kq square is taken out, and we are left with 2 root 2 plus 1. So this is the moment when we place all the values. So it's going to be 50 times 9 times 10 raised to 9, and q square is going to be 4.15 square times 10 raised to minus 6. Why minus 6? Because this is minus 3, and minus 3 square is minus 6. And we already have 2 root 2 plus 1 over here. That's 2 root 2 plus 1. So let me grab my calculator and get the value of this particular expression. It's 50 times 9 times 4.15 square times 2 root 2 plus 1. That's coming as we have over here. Let me just, this is 4.15. All right, so this is coming as uh, 2 point, this is coming as 29670.79 times 10 raised to 3. So let me just recheck my calculations over here. All right, so this is in newtons. So this is the required force, magnitude of the force for all the charges, but the direction is gonna remain, gotta change. So the direction I'm gonna point in this particular, in this new figure. So if this is how the square looks like, then the F net on this charge is got to be F net is over here, and this is at an angle of 45 degrees. Likewise, we have the other one also facing along the diagonal, which is again at an angle of 45 degrees on this charge. Likewise, this is also F net over here again at an angle of 45 degrees. And the last one is also over here again at an angle of 45 degrees. So these are the four forces, and this is the value of the F net, which will remain the same for all the four charges. Thank you.